Andrewng is a British-American globally recognized leader in AI. He is the founder of DeepLearning.AI, founder and CEO of Landing.AI, general partner at AI Fund, chairman and co-founder of Coursera, and a professor at Stanford University's Computer Science Department. In a recent talk at Sequoia, one of the most legendary Silicon Valley venture capital firms ever, he spoke about the power and the future of AI agents, which is very important to listen to.
All of you know andrewng as a famous computer science professor at Stanford, was really early on in the development of neural networks with GPUs, of course a creator of Coursera and popular courses like DeepLearning.AI, also the founder and creator and early lead of Google Brain. But one thing I've always wanted to ask you before I hand it over, Andrew, while you're on stage, is a question I think would be relevant to the whole audience. 10 years ago, on problem set number 2 of CS229, you gave me a B. And I was wondering, I looked it over, I was wondering what you saw that I did incorrectly. So anyway, Andrew.
Thank you, Hansin. Looking forward to sharing with all of you what I'm seeing with AI agents, which I think is an exciting trend that I think everyone building in AI should pay attention to. And then also excited about all the other what's next presentations. So AI agents, today the way most of us use large language models is like this, with a non-agentic workflow where you type a prompt and generates an answer. And that's a bit like if you ask a person to write an essay on a topic, and I say, please sit down at the keyboard and just type the essay from start to finish without ever using backspace. And despite how hard this is, LLMs do it remarkably well. In contrast, with an agentic workflow, this is what it may look like. Have an AI, have an LLM, say, write an essay outline. Do you need to do any web research? If so, let's do that. Then write the first draft, and then read your own first draft and think about what parts need revision. And then revise your draft, and you go on and on. And so this workflow is much more iterative, where you may have the LLM do some thinking, and then revise this article, and then do some more thinking and iterate this through a number of times. And what not many people appreciate is this delivers remarkably better results. I've actually been really surprised myself working these agent workflows, how well they work. I'm going to do one case study. My team analyzed some data using a coding benchmark called the Human Eval benchmark, released by OpenAI a few years ago. But this says coding problems like, given the non-empty list of integers, return the sum of all the odd elements or uneven positions. And it turns out the answer is a code snippet like that. So today, a lot of us will use zero-shot prompting, meaning we tell the AI, write the code and have it run on the first pass. Like, who codes like that? No human codes like that. You just type out the code and run it. Maybe you do. I can't do that. So it turns out that if you use GPT 3.5, zero-shot prompting, it gets it 48% right. GPT-4, way better, 67% right. But if you take an agentic workflow and wrap it around GPT 3.5, say, it actually does better than even GPT-4. And if you were to wrap this type of workflow around GPT-4, it also does very well. And you notice that GPT 3.5 with an agentic workflow actually outperforms GPT-4. And I think this has, and this means that this has significant consequences for I think how we all approach building applications. So agents is a term that's been tossed around a lot. There's a lot of consultant reports talk about agents, the future of AI, blah, blah, blah. I want to be a bit concrete and share with you the broad design patterns I'm seeing in agents. It's a very messy, chaotic space. Tons of research, tons of open source. There's a lot going on, but I try to categorize a bit more concretely what's going on in agents. Reflection is a tool that I think many of us should just use. It just works. Tool use, I think it's more widely appreciated, but actually works pretty well. I think of these as pretty robust technologies. When I use them, I can almost always get them to work well. Planning and multi-agent collaboration, I think of it as more emerging. When I use them, sometimes my mind is blown for how well they work. But at least at this moment in time, I don't feel like I can always get them to work reliably. So let me walk through these 4 design patterns in the next few slides. And if some of you go back and yourself will ask your engineers to use these, I think you get a productivity boost quite quickly. So reflection, here's an example. Let's say I ask a system, please write code for me for a given task. Then we have a coder agent, just an LLM that you prompt to write code to say, def do task, write a function like that. An example of self-reflection would be if you then prompt the LLM with something like this. Here's code intended for a task, and just give it back the exact same code that it just generated. And then say, check the code carefully for correctness, sound efficiency, good construction criticism. Just write a prompt like that. It turns out the same LLM that you prompted to write the code may be able to spot problems like this bug in line 5, maybe fix it by blah, blah, blah. And if you now take its own feedback and give it to it and reprompt it, it may come up with a version 2 of the code that could well work better than the first version. Not guaranteed, but it works, often enough for this to be worth trying for a lot of applications. To foreshadow tool use, if you let it run unit tests, if it fails a unit test, then why did you fail the unit test? Have that conversation and be able to figure out, fail the unit test, so you should try changing something and come up with V3. By the way, for those of you that want to learn more about these technologies, I'm very excited about them. For each of the 4 sections, I have a little recommended reading section at the bottom that hopefully gives more references. And again, just to foreshadow multi-agent systems, I've described as a single coder agent that you prompt to have it have this conversation with itself. One natural evolution of this idea is instead of a single coder agent, you can have 2 agents, where one is a coder agent and the second is a critic agent. And these could be the same base LM model, but that you prompt in different ways. We say one, you're expert coder, write code. The other one say you're expert code reviewer, so review this code. And this type of workflow is actually pretty easy to implement. I think it's such a very general purpose technology for a lot of workflows. This would give you a significant boost in the performance of LMs. The second design pattern is tool use. Many of you will already have seen LLM-based systems using tools. On the left is a screenshot from Copilot. On the right is something that I kind of extracted from GPT-4. But LLMs today, if you ask it what's the best coffee maker, can do a web search for some problems. LLMs will generate code and run code. And it turns out that there are a lot of different tools that many different people are using for analysis, for gathering information, for taking actions, for personal productivity. It turns out a lot of the early work on tool use turned out to be in the computer vision community, because before large language models, LLMs, they couldn't do anything with images. So the only option was to have the LLM generate a function call that could manipulate an image, like generate an image or do object detection or whatever. So if you actually look at literature, it's been interesting how much of the work in tool use seems like it originated from vision, because LLMs were blind to images before, GPT-4V and Lava and so on. So that's tool use, and it expands what an LLM can do. And then planning, for those of you that have not yet played a lot with planning algorithms, I feel like a lot of people talk about the ChatGPT moment where you're, wow, never seen anything like this. I think if you've not used planning algorithms, many people will have a kind of a AI agent. Wow, I couldn't imagine an AI agent doing this. I've run live demos where something failed and the AI agent rerouted around the failures. I've actually had quite a few of those moments where, wow, can't believe my AI system just did that autonomously. But one example that I adapted from a Hugging GPT paper, you say, please generate an image where a girl is reading a book, and it poses the same as a boy in the image, example.jpg, and please describe the new image with your voice. So give an example like this. Today with AI agents, you can kind of decide, first thing I need to do is determine the pose of the boy, then find the right model, maybe on Hugging Face, to extract the pose. Then next, need to find a post-image model to synthesize a picture of a girl as following the instructions. Then use image to text, and then finally use text to speech. And today we actually have agents that I don't want to say they work reliably. They're kind of finicky. They don't always work, but when it works, it's actually pretty amazing. But with agentic loops, sometimes you can recover from earlier failures as well. So I find myself already using research agents for some of my work where I'll want a piece of research, but I don't feel like Googling myself and spend a long time. I should send to the research agent, come back in a few minutes and see what it's come up with. And it sometimes works, sometimes doesn't, right? But that's already a part of my personal workflow. The final design pattern, multi-agent collaboration. This is one of those funny things, but it works much better than you might think. But on the left is a screenshot from a paper called ChatDev, which is completely open, which is actually open source. Many of you saw the flashy social media announcement of demo of a Devin. ChatDev is actually open source. It runs on my laptop, and what ChatDev does is an example of a multi-agent system where you prompt one LLM to sometimes act like the CEO of a software engineering company, sometimes act like a designer, sometimes act like a product manager, sometimes act like a tester. And this flock of agents that you build by prompting an LLM to tell them, you're now a CEO, you're now a software engineer. They collaborate, have an extended conversation so that if you tell it, please develop a game, develop a Go Monkey game, they'll actually spend a few minutes writing code, testing it, iterating, and then generate a surprisingly complex programs. Doesn't always work. I've used it. Sometimes it doesn't work. Sometimes it's amazing. But this technology is really getting better. And just one of the design pattern, it turns out that multi-agent debate, where you have different agents, for example, it could be have ChatGPT and Gemini debate each other. That actually results in a better performance as well. So getting multiple simulated AI agents work together has a more powerful design pattern as well. So just to summarize, I think these are the patterns I've seen, and I think that if we were to use these patterns, in our work, a lot of us can get a productivity boost quite quickly. And I think that agentic reasoning design patterns are going to be important. This is my last slide. I expect that the set of tasks AI could do will expand dramatically this year because of agentic workflows. And one thing that's actually difficult for people to get used to is when we prompt an LM, we want a response right away. In fact, a decade ago, when I was having discussions at Google on we call it a big box search, we type in a long prompt. One of the reasons I failed to push successfully for that was because when you do a web search, you want a response back in half a second, right? That's just human nature. We like that instant feedback. But for a lot of the agent workflows, I think we'll need to learn to dedicate a task in AI agent and patiently wait minutes, maybe even hours for a response. But just like I've seen a lot of novice managers delegate something to someone and then check in 5 minutes later, right? And that's not productive. I think we need to, it's really difficult. We need to do that with some of our AI agents as well. I heard some laughs. And then one other important trend, fast token generation is important because with these agentic workflows, we're iterating over and over. So the LM is generating tokens for the LM to read. So being able to generate tokens way faster than any human to read is fantastic. And I think that generating more tokens really quickly from even a slightly lower quality LM might give good results compared to slower tokens from a better LM, maybe. It's a little bit controversial because it may let you go around this loop a lot more times, kind of like the results I showed with GPT-3 and an agent architecture on the first slide. And candidly, I'm really looking forward to Claude 4 and GPT-5 and Gemini 2.0 and all these other wonderful models that many people are building. And part of me feels like if you're looking forward to running your thing on GPT-5 zero shot, you may really get closer to that level of performance on some applications than you might think with agentic reasoning, but on an earlier model. I think this is an important trend, and honestly, the path to AGI feels like a journey rather than a destination. But I think this type of agent workflows could help us take a small step forward on this very long journey. Thank you.